ఫోన్ చేసిండ్రా.
Good morning, everyone. My name is KG1. Today, my subject theory of structures. Today, my topic experimental investigation of the wind loading on solar panels, effects of clearance of flat roofs. Title and introduction. This presentation explores the experimental investigation of wind loading on solar panels installed on flat roofs. It examines how varying clearance between the panels and the roof surface influence wind force. Understanding these efforts is crucial for optimizing solar panels designing and ensuring structural safety. Background and moderation. Solar panels are increasingly installed on flat roofs in urban environments. Wind loads can significantly impact the structural integrity and performance of these panels. The clearance distance between panels and roof can alter wind flow patterns and loading characteristics. Objective of the study to experimental quantify wind force on solar panels with different clearance heights to analyze the influence of clearance on wind, pressure distribution on flow behavior to provide recommendations for safer and more efficient solar panel installation on flat roofs. Experimental setup and methodology. Wind tunnels tests were conducted using scaled models of flat roof solar panel arrangements. Various clearance heights were tested to simulate real-world installation scenarios. scenarios. Pressure sensors and flow visualization techniques were employed to measure wind loads and flow patterns. Model dimensions and materials. The models were constructed with high lightweight materials to accurate replicate the aerodynamic properties. Clearance ranged from close to roof contact to significant gaps. For example, 0 centimeters, 10 centimeters, 20 centimeters. The solar plants were modeled with operated surface roughness to simulate real panels. We observe in model dimension, they have clearance ranged for closer to roof contact. They give some significant gaps. For example, one is 0 centimeters, another 10 centimeters, and 20 centimeters. And in the model we constructed the lightweight materials to accurate the reflecting aerodynamic properties. The solar panels we used modeled with simulate real panels. Result wind pressure distribution. Increasing clearance generally reduced peak wind pressure on the upper surface of the panel. Flow, separation, and vortex formation were observed to vary with different clearance. The data indicate a complex relationship between clearance, height, and local wind pressure. We observe the result like the wind pressure distribution. When the increasing the clearance, they reduce the peak wind pressure, and the upper pressure of the panels they easily clearance to increasing. The flow of separation of vortex formation we observe the vary with different clearance, and we so much data collect a complex relation between clearance and height and local wind pressure in main we observe. Result flow patterns and vortex formation. Visualization revealed that large clearance promoted the development of prevalent vortex structure. This vortex is influence the overall wind load distribution across the panels. The finding suggests the optimally clearance can minimize advisor aerodynamic effects. You observe the flow patterns, they have visualized the related to large clearance to promote to development the vortex structural. They and they overall the wind load is distributed across the plant to overall the flow pattern. They suggest the optical clearance and advise the minimize. Discuss and implications. Proper clearance adjustment can significantly reducing wind induced stress or solar plant. The study highlights the importance of considering with flow dynamics in installation designing. Result can inform guidelines for safe and durable solar plants mounting on float roofs. In implementation, they we observe the proper clearance adjust can significantly, and they reducing the wind indicate and stress on solar plants. The main highlight the importance of considering wind flow and dynamic installation designing. Conclusion and recommendations. Experimental evidence show the clearance height impact with loading on roof mounted solar plants. A moderate clearance may offers a optimal balance between structural safe and airflow efficient. Future work should include field validity on the effects of varying wind direction and speed. In the conclusion, mean the experimental and the clearance height and impacting of and loading the roof mountain the solar panels to moderate and may efforts on optim that's in there. Once we recall future work should title and introduction. The presentation explores the experimental investigation of wind loading on loading solar plants initialized on floods roof. The background and motivation. Solar panels are increasingly installed on flat roofs or urban environments. Winds loads can significantly impact the structural integrate and for performance of these panels. The clearance distance between panels and roofs, the wind flow patterns and loading characteristics. Objective of the study. The experimental phase of wind force on solar panels with different clearance heights to analyze the influence of clearance to wind pressure distribution and flow behavior to provide the recommendations for safer and more efficient solar panels installation on flat roofs. Experimental setup and methodology. Wind tunnel tests were under using the scale model of flat roofs panel arrangements. Various clearance sites were the tested to simulate real-world installation. Yes, the pressure sensors and flow visualization techniques were employed to measure wind loads and flow patterns. Model dimensions and materials to model were stood with lightweight materials to accurately replicate the aerodynamic property. Clearance ranged from close to roof contact to significant gap, for example, 0 centimeters and 10 centimeters and 20 centimeters. The solar panels were modeled with applicator surface roughness to simulate real panels. Result wind pressure distribution. Itself, parents generally reduce the peaks wind pressure on the upper surface of the panels. The data indicated a complex relationship between clearance height and local wind pressure, flow pattern, and vortex formation. We'll also recall this. The finding of suggest to optimal clearance can minimize advisor aerodynamic effects. Conclusion and recommendations. Reference. Thank you.